Emerging trends in cloud computing, right? So cloud computing has been evolving at a very fast pace. Lot of new features and lot of new components have been added into the cloud computing, right, which made cloud computing more powerful and more easily accessible to the users. Okay, so we will see some of the important trends in the cloud computing. The first one is the serverless computing, right? This is one of the very recent trend in cloud computing, and this is going to be the future, because in serverless computing the developer need not verify anything or need not worry about the infrastructure or the hardware part. His job is only to write the code and forget about the scalability of the code what he has written, or the allocation of the resources what he has to do, right? All that he has to forget. That is why this is one of the most recent trend. Okay, so serverless computing is a cloud computing execution model where cloud providers automatically manage the infrastructure required for running the applications. We see, if when there is sudden spike in the application what you are deploying or your application, right, some adjustment have to be done if you are using on premise. Even in cloud you have to worry about that. You have to go and check, but in serverless computing, the infrastructure to run the application, you need not worry about. 100% it guarantees that it will take care of all that. But it is not only at this point, it is more beyond. Serverless is more beyond what we are saying, right? So FAAS is the popular implementation of serverless, right? Function as a service. Okay, right? So it allows developers to focus purely on writing code without worrying about provisioning, managing or scaling the servers, right? So you need not worry about the provisioning and scaling of the servers. The name serverless is bit misleading because it says serverless, but actually serverless is for the user view. In the user's perspective, he is having no server, or he is not worried about the server, but actually the cloud provider is taking care of that, right? So this is about the term serverless. So from the developer perspective, he has no need to worry about the servers, right? So he need not worry about the server part. Okay, so only that's why it is misleading. It has server exists. It is in the provider's perspective. For us as developers, we need not worry about the servers, right? What are the benefits? No server management. Pay only for what you use. Continuous scaling. It is continuous. The services what you are writing, it is continuously being scaled, and built-in fault tolerance. Okay, if some issue is there, that will be automatically taken care, right? Then there are two types of serverless architectures. One is function as a service, the second one is backend as a service. So what is this function as a service? It is a serverless architecture that developers can use to write custom backend functions. Backend code can be written as functions. In small functions can be written and deploy the function code directly to the cloud infrastructure, right? So when a function is called, the cloud provider runs the function on an existing active server or spins up a new server if required. So the backend code is not active. We have written it, it is there in the cloud, that's it. When a new request comes, it activates that, it initiates the service and function, invokes the function and gets the output, and again it can be pushed into idle state. So you need to pay only for what you are using, okay, not continuously running in the cloud. Basic cloud computing, when you have a service, it is continuously running, whereas in serverless it will be in idle state if there is no request for that. Only when a new request comes, it will be activated and the response will be given to us, right? So developers can write and deploy code without worrying about how and where it executes or runs. Okay, then the next one is backend as service, right? So the backend code is written already and exposed through API. Okay, so backend as a service gives developers access to backend functions using an API, right? So in their serverless environment, cloud vendors give API based access to extra encryption, authentication and cloud accessible databases. So there are some services in the cloud which can help, which can be used by us as the backend, right, which can help us in doing our business, right. So this is about the serverless computing. The second one is edge computing, right. So when we talk about IoT, we talk about edge computing. Okay, so what are the drawbacks of the cloud computing? Transmitting large amount of data to the cloud in real time will cause great pressure on the bandwidth. As more and more services are being deployed in the cloud, it has become a big challenge to keep the 24/7 promise. The size of the cloud platform or the services what cloud providers are giving, it has increased a lot, right. So edge computing is a distributed architecture in which client data is processed at the periphery of the network as close to the original source as possible. So wherever the data is being produced, there only we can have a small infrastructure which can data can be processed there and some decision can be taken. You need not move to and fro from the cloud center to the data generating source. Data processing is done where the data is actually generated. So it has emerged with the exponential growth with the growth of IoT devices, right. So we have some terminology in edge computing. First one is edge device. A device which produces data is an edge device. Okay, something like machine or sensors, right. The second one is edge gateway. It's a buffer where edge computing processing is done. Then we have edge server, a computer located in a facility close to the edge device. Okay, and node, anything, any device which is performing or involved in edge computing is called as edge node. So generally in research papers and in general terminology, we refer the server, the device, the gateway as node, right, that is edge node. So this is the simple architecture of edge computing. See, we have device layer, lot of devices are there, these are generating the data, right. Then we have edge layer where we have some small edge servers here, small infrastructure which can take this data, store there, aggregate them, do some processing or pre-processing kind of thing can be done here, and some decisions can be taken. And if these decisions, we are unable to take some decision, then we can send the data to the cloud and there we can run the algorithms and take some decisions, right. So there are three layers in the edge computing architecture: device layer, edge layer and the cloud layer, right. The next trend is cloud AI. So the amalgamation or the combination of cloud and AI, okay, can be called as either AI cloud or cloud AI. This combination has become one of the most groundbreaking fusion of technologies. Why? Because it gives lot of advantages to us. In what sense? Let's see. See, AI algorithms, to run AI algorithms, we need lot of computation facility, and cloud has that. You need GPU, you need elasticity, you need TPU, cloud has that. So for that reason, AI and cloud are linked. Cloud also needs intelligence. In the cloud services, they need to have some AI based optimization technique or AI based schemes or algorithms which can automate their job or make their cloud services better. So for cloud, when the cloud need intelligence, AI does that, right. Business need rapid AI deployment. We need to deploy AI applications as quick as we are deploying the other web applications, for example, right. Cloud is providing MLOps, like DevOps pipeline, cloud is having MLOps pipeline which will automatically do every step without our involvement. And the data is increasing like anything in the cloud. Data volumes are increasing, right. So for that, cloud is the global data reservoir. Cloud can store as much as data as you want to give. The whole world's data can be stored in the cloud. That is possible. So cloud providers are so powerful that they have unlimited storage, but virtual unlimited storage, right. So this is about the third emerging trend, that is cloud AI. And the final one is green cloud. One of the most happening thing in cloud is green cloud, because the whole world is worried about the energy and the power and the wastage what we are generating from the IT, right. So we are every sector of the industries, every sector of industries are trying to bring up this concept of green, right, green energy, okay, green wind, all that is coming into picture now. So green cloud computing integrates sustainability across infrastructure, operations and design. Sustainability means again taking care of the reducing waste and having saving some power, saving energy, saving money, all that comes under sustainability, and that should be integrated in the infrastructure, in the operations and the design. Everywhere you have to bring the sustainability, ensuring that the systems powering AI innovation evolve responsibly. Right? There are 6 pillars of green cloud computing. The first one is energy efficiency. So optimizing server and the data center design so that we minimize idle power, draw and heat waste. Right? So whatever power is being utilized, that one and the heat waste should be optimized or minimized. Okay. The second one is renewable energy. So instead of using electricity, you may go for solar, wind and hydro sources, right? Reducing reliance on the fossil fuels like coal or other gas and oils, right? The third one is data center location. Build the facilities near the renewable supply. Wherever there is renewable supply, you build it there, because you can reduce the cost of shifting the coal from that mine to this data center or to the power generating source, from there to the data center. Wherever there is power, or you may construct your data centers at cooler climates to improve efficiency. Some chilling place you can have your data center, right? The fourth one is containerization. Okay, containers, basically cloud containers can deploy applications very quickly in less time. Right? So we may use containers so that deployment is less. When deployment is less, the power consumption or the computation facility required is less. When it is less, everything required for that also reduces. Right? Using virtualization and orchestration platforms like Kubernetes to maximize utilization and scale on demand. Fifth one is efficient cooling systems. Okay, deploying AI assisted and liquid cooling methods to lower overall power consumption. That also should be taken care. And the final one, e-waste reduction. Okay, so the hardware waste, the keyboards, the monitors which are not used, right? We keep throwing them always. Lot of dump is being generated, hardware waste. So extending hardware lifespan through reuse and responsible recycling. Proper care should be taken care of the hardware so that their lifespan increases. Right? So this is the fourth emerging trend in cloud computing. So the 4 emerging trends in cloud computing, the first one is serverless, then the edge computing, third one is cloud AI, and the fourth one is green cloud. Okay.